Hi, this is Asing. You are now watching Asing Math TV. Today we'd like to share how to solve this complex equation. Firstly, we can consider to reduce this complex function as a function of the product of two quadratic functions. In other words, we should have a leading term with the term z squared, and the next term should have z with coefficient m and n respectively. For the constant term, let's consider the constant of the original function, that is the term 26. All we need to do is to determine all the prime factors of 26. There are 2 and 13. If the prime factors do not help us to solve the equation, only then we determine other factors such as 1 and 26. Let's form equations based on the coefficient of the term z squared using the prime factors. So we should have negative 1. With the prime factors, it is either both negative or both positive. Since 26 is a positive number, in other words, it should be negative multiply negative, we get positive, or positive multiply positive, we get back positive. Don't forget, if we take mz multiply nz, we will get a term with z squared as well. So we should have m multiply n. Since z cubed is missing from the original equation, which means that the coefficient is equal to 0. Therefore, this implies that if we take mz multiply z squared, that is z cubed, plus nz multiply z squared, again z cubed, we should obtain 0. Therefore, m should equal to negative n. Let's rewrite the equation. We should have negative 1 is equal to negative 2 minus 13 minus m squared, or it is equal to 1 is equal to 2 plus 13 plus m squared. On the other hand, we should have negative 1 is equal to 2 plus 13 minus m squared. The first possibility should be rejected, since m squared is always a positive number. In other words, if we take 2 plus 13 plus m squared, it would definitely greater than 1, but not equal to 1. So the constants should be two positive numbers. So let's write it here. We should have positive 2 and positive 13. Now let's solve for m algebraically. We should obtain m squared is equal to 16, or equivalently m is equal to plus minus 4. Next, what we have to do here is to determine whether m is positive or negative 4. Very simple. Let's consider the coefficient of z of the original equation, that is 44. To get this term, we should either take 2 multiplies n or 13 multiply n. To fulfill this equation, m must be equal to 4 while n is equal to negative 4. Therefore, the two quadratic functions are z squared plus 4z plus 2 multiply z squared minus 4z plus 13 is equal to 0. Let's solve each quadratic function by using the quadratic formula. So we should have z is equal to minus 4 plus minus square root of 4 squared minus 4 multiply 1 multiply 2 divided by 2 multiply 1. Simplified, we obtain negative 4 plus minus square root of 8 divided by 2, or equivalently it should be negative 2 plus minus square root of 2. On the other hand, for the second quadratic function, we shall have z is equal to 4 plus minus square root of 4 squared minus 4 multiply 1 multiply 13 divided by 2 multiply 1. Simplified, we have 4 plus minus square root of negative 36 and divided by 2. Take note that in complex number, negative 1 is simply I squared, which means that negative 36 can be written as 36I squared. So we should have 2 plus minus 3I, and hence we done. Okay, that's all for this video. Thanks for watching. Hope you like this. See you!